Hi, so this is the Tmua 2021 Paper 2 Question 20. Now, as you'd expect from Question 20 on either of the two papers, this is going to be hard. It's particularly hard usually when it's Paper 2 because you've got all of these kind of logic questions. Now, this one is sort of screaming out for a small test case, or testing small cases, because the idea of expanding this function 99 times or iterating it 99 times just seems a bit ridiculous. So let's have a think about what f of 1 is and integrating that. So if we think about f of 1, that's going to be just a function like this because you got that symmetry in the y-axis, and of course between 1 and -1, that's just going to have an integral of 1 because of the area beneath that. Now, so that's f of 1. If we think about f of 2, we've then got the integral between -1 and 1 of f of 1, which is mod x plus x. Now, typically when you're doing things with mod graphs, when x is positive, it's no different. The modulus sign isn't really adding anything as long as we're not going into negative numbers anyway, which we wouldn't be here because we've just got x mod x plus x. So we might want to think of this as the integral between -1 and 1. Sorry, -1 and 0 even, plus the integral between 0 and 1. Now, the integral between 0 and 1 is just going to be 2x dx. As I said, that those mod signs aren't actually doing anything. This integral is interesting because actually the modulus sign here is making x into the negative of what it actually is, because the x values between -1 and 0 are negative, so the modulus is then positive, but this x is still negative, so you actually end up just integrating 0 here. Now, that means that this positive x part is just a steeper version of f1. We've got a gradient of 2 instead, but it still passes through the origin. And we're still only going up to -1. It's just that in terms of the x values, so you mentioned the triangle, getting taller and taller and taller, so we're sort of going to have a triangle there instead. Now, if we think about f3, well, we'll do that. Again, we'll split it up. We've then got integral between -1 and 0 dx plus the integral between 0 and 1 of 3x dx. Because again, if we just keep adding more x's, because our f3 is going to be the mod of mod x plus x mod of plus x mod. And it just becomes a bit mind-bending, really, once you start throwing all these modular signs in. But we know that these modular signs are doing nothing when x is positive, so we can just write that as 3x. Now, we already know that this is going to be 0, this bit here. So if we add another x onto that, that's then going to be sort of below the axis, but then because we take the mod of it, goes back to the axis. So this bit here is essentially 0, and so we just end up with the left-hand side being this bit again. It's just this bit. And then if you can kind of see the pattern then, f4, this bit on the left is going to be 0, f5 is going to go back to the same as f1, then 0, then f1, then 0. So if we think about f99, the integral between -1 and 1 of x dx, the right-hand side is going to be like this, where we're going to have 1. This is going to be 99, so that area is going to be 1 times 99 divided by 2, 49.5. And on the left-hand side, because it's an odd number, so here, we're going to essentially have this mod x here. The left-hand side is then just going to be this, which is 0.5. And we end up overall with 50, which is E.